Hello wonderful students, and welcome to my presentation about using AI in software development. I am not an expert on AI by any stretch of the imagination. I am a computing teacher and this is intended for my VCE classes, so you might find it useful in that context, but if you're looking for actual expertise, I would suggest you go elsewhere. So let's have a look first of all what we're looking for in the study design. The study design wants us to understand about using prompts to generate code, automatic debugging and testing of modules, code optimization, and responsible and ethical use of AI. I'm going a bit broader in what I'm talking about today. I don't think that the broader material I'm going for is likely to be on the exams, but I think it's good to have an understanding of how things work in a larger context, and I also think that it's just an increasing part of the world. It's good to know how the world works. I think there's a lot of misconceptions out there and a lot of legitimate concerns about AI. So let's have a look at it. So first of all, what do we already know? So what is generative AI? Is it a type of software that can create new content like text, images and music based on patterns it's learned? Is it a type of software that searches the internet and copies existing content? A type of software that can think and reason like a human brain? Or is it a type of software and hardware that generates electricity to power computers? So I'm going to have a sip of my drink while you think about that. In actual fact, the answer is one. It can create new things based on patterns that it's learned. This second one is a common misconception about AI, and sometimes AI will bring you back somebody else's content. I've noticed recently when I was using Google Gemini, and I asked it for some information for the wiki, which is in this other window here, and it actually came back with an image that was watermarked from, I think, from one of the commercial sites. So it does happen. Can it think and reason like a human? No, they do talk about heading for a generalised AI. I think we're some distance off that, but that's not where we're at the moment. Okay, the next question. How does generative AI create its responses? Does it search the internet in real time and copy information from websites? Does it have a human operator who types responses very quickly? Does it use patterns learned from training data to predict and generate likely responses? Or does it store every possible question and answer in a giant database? Now, I think from the first question, you probably know the answer to the second question, but interestingly, in terms of number two, there was a coding AI which actually did have human operators at the other end. They actually didn't get it up to the level of what they were marketing it as. So they actually did, two was kind of true in that situation. I don't actually understand how it was fast enough for people to think that it was a computer doing it, because when I'm using generative AI to write code, it might take a minute or two to generate a couple of hundred lines of code, but I wouldn't have thought that was a speed that a human could do that at. But I don't know, I'd have to look into it. What's the limitation of the current generative AI systems? They sometimes produce incorrect information, confidently predicted as fact. They are too slow to be useful in everyday tasks. They can only find existing answers and cannot synthesize information. They require a supercomputer to run and cannot work on normal devices. So I'll give you a second to think about what your answer is there. So, in actual fact, it is the first one. They sometimes produce incorrect information, and this is called hallucinating. And it will just say, "Yep, this is the correct answer." So you shouldn't take anything generated by AI as life and death fact. I think it's okay if if the stakes are low, and if a little bit of misinformation isn't going to kill you or anyone else, or cause harm, but I think that it works best when you keep your brain switched on and you evaluate it critically and think, hang on, does that look right? Because even on simple tasks, you see these on the internet all the time, people will put maths problems or how many of this letter in this word, and it just gets it wrong. It's, it is not really, it's not too slow. Like it's faster than all the other options. It can synthesize information. If you ask it a situation about, a hypothetical group of friends and you describe the dynamics between them, it will actually unpack it and make things that appear to be intelligent. I know it's not intelligence like human intelligence, but it's surprising that in how it synthesises old information into new information. And in actual fact, yes, it takes a lot of computing power, but you have AIs that will run on most modern machines. Now, here's another question to see what we already know. What does training data mean in relation to Gen AI? These are the questions that users ask the AI system every day. Instructions that the programmers type in to tell the AI what to do. Large collections of examples that AI learns patterns from before it's released. And 4 is the practice exercises that AI completes to improve itself over time. Now, actually, a bit like a VCE exam, one of these questions is better than the other, one of these answers is better than the other, and none of them are perfect. So, lock in your answer. I think the best answer is 3. It looks at large collections of examples and it learns the pattern. Not only before it's released, most of these systems are actually constantly upgraded. And in actual fact, one is kind of true in that it puts the text from your questions, it analyses them and says, you know, what can I learn about the world and the relationship ideas from this extra text I'm being provided in the form of prompts. There are systems that sometimes government departments use, and I suspect some corporates, where information can come into the organisation, but none of the stuff that users type in can be worked into the greater model. And that's a way of addressing concerns about privacy. And it says, number 2's a little bit true too. AI doesn't learn all on its own. There is human intervention. A famous example of this is the AI that's built into Twitter, which, as the time of taping, is programmed, I think, to basically never criticise the owner of that company, or the major owner of that company, so that if you ask it, like, who's more important, him or the population of a particular European country, it will always choose him. So, yeah, absolutely, people tinker with the way that AI thinks. So, what does AI do? Well, it uses deep learning techniques, that's an interesting term, to analyse massive training data sets. So much like you look at the world and you generate ideas in your own head about the correlation between what the sky looks like before it's going to rain, whether the traffic's going to be heavy when there's footy on that day, how a particular person is going to behave, and you're building up theories, it's building up connections. From looking at huge amounts of text, which is a little bit like what we do over our lifetime. It can identify complex patterns in a way that I think we can do, but it can do it on a really large scale. And it can say, okay, well, if A does this and B does this and C does that, then this is what D will probably be. And it generates probabilistic content. So if you're typing the quick black fox jumped over thee, or the lazy dog, it will often think, oh, well, it's most likely that the next thing they're going to type is this. And you'll notice this in things like Google Docs. If I'm typing functional and non-functional requirements, the little grey text will come out. I'll type functional, and it'll be and non-functional requirements, because that's generally what people type and also what I type. It's building up the context of the last a few things that I said. I don't know quite how many it is these days, but it's actually working on the context of the conversation you've had with it. So that's how it kind of reads your brain and just goes, oh yeah, this is the context of what they're talking about. And it creates new outputs. So this photo here, for instance, this is not based on another photo. This is a, I hesitate to use the word original, but this isn't just a copy of some other photo. It has put it together based on the prompt that I fed it. Okay, let's look at the core technologies, because people often talk about one of these when they're talking about AI, and I'm talking about large language models, but there are actually 4 technologies at the core of how it works. And again, I'm talking in December 2025. This may be different by the time you watch this. There's large language models, there's neural networks, machine learning algorithms, and transformer architectures. So let's have a look at the large language models first. This is a system which is based on massive amounts of data to understand and generate human language. This is probably one of the moral and ethical and legal issues in terms of AI, in that people have been scanning information on the internet for more than 20 years now. You know, this is kind of what's amazing about things like Bing and Google and so forth, is that they're not just looking for exact hits. This is what search engines did in the very early days. but they're building up models of what you said and what's on this page, and they're basically representing them as kind of correlations between ideas and saying, well, when they're talking about the most beautiful dog, they might also be talking about a handsome dog or a pretty dog or a gorgeous dog. That it has all of those connections, just goes, oh yeah, these words are tightly clustered together. So people have been, this is kind of what humans do in education. You take in a whole lot of information and you synthesize it. But the difference here is that this can also create things, and I think that creates a whole new level of discomfort and concern. When it was just, well, it's helping me find something, then we kind of were fine with it scanning large amounts of stuff without permission. But when it's actually using that information to create something, then I think that's what people are concerned about. I think it's actually more a ethical issue than a legal issue, although there was recently a case with Claude who paid out authors whose books they'd used as training data something in the vicinity of $1.6 billion, which I think was sort of $2,000 to $3,000 per author or per text. So it's playing out in both of those spaces. If what they're doing is learning the statistical patterns and relationships by looking at millions of examples, probably trillions of examples. So that a sentence will often start with a definite article, a or the. That we capitalise at the start of sentences. That when we talk about fluffy for a dog, it means a particular thing, but when we talk about fluffy thinking, we're actually using fluffy to mean something different. And it's building up those relationships in a mathematical way that it can put into practice. And it develops an understanding for grammar and context and facts and reasoning, so that you can actually say, well, even when you've never seen this situation before, what do you think would come next? Now, there are spectacular cases where this falls down. I use it occasionally when I'm making a puzzle. If this train's travelling at this speed and this train's travelling at this speed, and it will completely misunderstand it. But that's fine. I think you want to take everything with a grain of salt. I'm okay with it being wrong because I don't expect it to be always right. Let's look at neural networks. Neural networks I actually haven't heard in the discussion much. So this is modelling what happens in your brain. So it's in your brain you have neurons that are organised in layers and they've got connections between them. And I think of neural networks as being a bit like walking across a field and making paths because you walk. And the more often you walk across that field, the deeper and more solid the path gets, and the more efficient it is for you to get across that ground because you've got a clear path. So the more you use a path, the more you make a connection between ideas, the stronger that connection gets, and your brain will go that way. And if you stop doing something, then it will overgrow again. So following this kind of model, this is how neural networks receive data. So they get data on one side, they're the light blue dots, and then they have what's called the hidden layer. And it's basically saying, oh, this connection we think is better than that connection. This connection happens more often. When I'm saying somebody's a prince, I'm more often talking about royalty, and I'm less often talking about, hey, you're a mensch, you're a prince. So it's building up those connections, I suspect, with training data, and then at the end it's creating output. So I don't have a deep understanding of this, but that's basically what I can tell you about neural networks. Machine learning is, again, there's some sort of overlap in these terms. Neural networks are a form of machine learning. You can have supervised learning, where you can actually say to it, here's the question, I want you to have a go at the answer, and then you'll go through and say, actually, this is the best of the responses. And I actually had a moment like this earlier. I asked for something, and it said, which of these is the best response? So that was a bit of supervised learning that it was getting me to do. You can do things like you could give it an XML file and say the following things are fruit and the following things are vegetables. And so you're giving it the classification and you're helping it learn by giving it some metadata. There's unsupervised learning. So you're actually going through and saying, well, you know what, when I see these things, when I say big brown, it's probably big brown bear rather than big brown dog or big brown cloud. So it's finding clusters of words and saying, hey, when this occurs too. There's that kind of correlation, which you can see there in the image. And then there's reinforcement learning, and that's where I was just actually having a bit of a swing of golf. So let's say it's got a robot, and it's hitting the ball, and it's saying, okay, when the robot does these things, the ball goes further. When the robot does these things, the ball is more accurate. So it's kind of testing itself. It's running its own science experiments. And it gives it rewards and penalties. So, if the ball goes less than a metre, well then, but there's a penalty on that solution. Let's discourage you from using that solution again because they've got such a bad result. When you're getting one 300 yards, then there's a real bonus. Let's reinforce that model so that you're not just randomly trying things. You're kind of building some up and dragging some down. Transformer architectures I had never heard of, and I think this image is almost entirely useless. It's what they call a self-attention mechanism. Now, I'm actually just going to go across here and have a look at this because this is one of these things that I struggled with. So, self-attention, it allows the model to weigh the importance of different parts. Okay, so if I say, the pugnacious dog ran through the blue door, that pugnacious is what's important, that it's a dog spoiling for a fight, not necessarily that the door is blue. So it doesn't get distracted by less important details. That you've got what they call an encoder-decoder structure, where the bit of software at this end taking the input is doing its own job in its own way, and the decoding of it is different again. I'm just going to have a look at that. Yeah, the encoder processes input and the decoder generates output. The positional encoding. Oh yeah, that some words, depending on where they're sitting in the sentence, will be more important than other words. And that would also, I suspect, interconnect with self-attention. So, thankfully we're almost at the end. This is one of the things on the VCE curriculum. So, using a prompt to generate code. So here's a good prompt. Act as an expert web developer and create a single HTML solution for a hangman game using HTML5, CSS3 and vanilla JavaScript. The game should select a random word from a list of 20 technology themed words. So that's a kind of one shot, like here's my description, out you go. What you can also do, particularly some of the models such as Cursor, and I noticed the Google one, I want to say it's called Infinity, but I think I might be getting that wrong. They'll actually have you in planning mode, so you can say, I would like a hangman game. What do you need to know? And it'll say, I have some questions. And it'll give you multiple choice questions, and it'll sort of have a conversation with you. Or you can do a combination of both of these things. So a prompt, and I think this is a common misconception, is not just a one-shot search term. Oh, I gave it this and it didn't work. They have the context of your conversation most of the time and can build on it in the context and have more and more understanding. Again, it doesn't result in perfection, but it's not just the same as a search term. It's not just you throw it over the wall, something comes back. You can throw it over the wall another time. Yeah, this is just more of their stuff there. I have started with big prompts like this. And it actually worked pretty well. I think if it's kind of fully realised in your head and you know really what the program's going to be and you know the language to use, then a fully formed prompt is a good idea. So we've got a thing for students to do in class, to write a prompt for a magic 8-ball. If you're having a look at this at home, I would write a prompt and then put it into a generative AI and say, please evaluate this prompt. What else would you need to know? It's okay if it wants to know more. This isn't in the curriculum, but I think it's really interesting that some of these services have these things called custom agents. I actually use these quite a lot. So what I do is I set one up, say to make these images, and I give it the parameters. I want this for an audience of senior high school students. I want it to be sort of clear and well lit. I want it to try and use analogies to talk about that rather than just a diagram that lists it in text. And I polish this up as I go. It's a work in progress. But it does mean that if you're doing the same sort of thing, rather than typing out these terribly long prompts, if you're going back to this one here, You might have an agent that knows that you want to create HTML solutions, what technologies you want to use, what preferences you have for it, and then you can just use that every time. So I think custom agents are really useful, and they assist with sort of multiple uses and being efficient so that you don't have to type out really long prompts all the time. Another thing that's in the study design is automated debugging and testing of modules. So I was recently creating something, and I just realised I need to go in and edit this so that I'm not giving away people's email addresses. And I asked it to make me a page to generate some test data. So this is something that I would have done manually before, and it actually would have taken quite a lot of time. But this actually goes in and it creates images and it creates stuff, and some of these even have checklists for me to go through, and it directs me how to do effective testing of this module. So I think that's new and really interesting. Code optimization is in the study design. This code over here is certainly working. I got the AI to generate this. This is the sort of code that I would write. Some even squares inefficient, so I'm creating an array or a list. We're going through a loop, we're using a modulo, we're adding up the list and we're returning it. This is more efficient. Now, it's shorter, obviously, but it also told me all of the ways in which it's more efficient. It's more memory efficient, it's faster, and it uses the speed of C, is what it means by C speed. So C is a lower level language, and it will run faster. So, you can actually improve on it. One thing that isn't in the presentation, but I often do, and I guess this probably fits into code optimization, is that I'll often write a query for an SQL database in PHP, and I just write it in a very standard way. But it is much more secure to have it parameterized. But I've never really got my head around how parameterization works. Like, I understand the concept of it, but when it comes to actually writing it, I often make mistakes. So what I will do is I will write it the way that I know to write it, and then I'll say, please parameterize this. I still need to test it. Again, it makes mistakes like I make mistakes. But in terms of making things more efficient and more secure, it's not always more secure, but if you know that parameterization is better than not, then that's what I can use it for. Now, this is probably the big issue of our age, the responsible and ethical use of artificial intelligence. So there is certainly misinformation. We had at the time of me recording this, we had a tragedy in a Sydney suburb, and very quickly certain AIs were generating absolutely incorrect information about who was involved in it, who was behaving dangerously, who wasn't, was actually naming incorrect people. So, this is a huge problem. The hallucinating that it does, the biases that are built into it. Some of the biases are not intentional, some of them are intentional. The one I was talking about earlier, where it puts the reputation of the shareholder of the company above things being factually correct. At least that's how I understand it. Yeah, absolutely. There's real issues about, and also, there've been horrible cases about, young people who've been relying on an AI, and the AI has egged them on to harm themselves. So this is a huge issue. Copyright and intellectual property challenges. It's not particularly respectful of copyright. It synthesizes stuff, and generally speaking, you can only copyright the implementation of something, not the ideas themselves. But you know what? I understand why it makes people queasy. I don't think we're that far off being able to say, okay, write me a new book in the style of Richard Osman, for instance, who writes the Thursday Murder Club books, that it would be able to imitate people. And you and I could already imitate people, and there would be issues about trademarks and so forth. But you'd actually have to be a pretty skilled writer to imitate somebody to the level where you could pass it off. Whereas potentially a machine could just do it with a prompt, please write me a space opera as if it was written by George Lucas. So I think we're getting into new ethical territory here, and people have legitimate concerns about it. The bias in the training data. If you have all this training data that says things that are biased along the way, like, if you think of how recently women couldn't vote and have their bank accounts and so forth, if you're training your AI on years and years and years of that sort of thinking, then that's what's going to come through. Those are the values that are going to come through, because that's the values that were there in the training data. And so that's a concern, because there's a whole lot of stuff that we could be training on which might not align with our values. And we have privacy concerns that, for instance, as a teacher, I can't put student data into the AI because I don't want it sort of making inferences about people based on the data. The privacy laws prevent that. So, and potential workforce disruption. There are people who are thinking that this might decimate middle-class intellectual jobs, including ones like mine, and mean that basically nobody wants to pay people when you can just have an AI generate things. There have been technologies like this that have been disruptive before, photographs supplanting drawing and painting, and, TV supplanting radio, and various forms of internet. But just because it's happened before doesn't mean that it's not a genuine concern. So there's quite a lot of ethical concerns. So, what do we know? In 30 words or less, what does a neural network do? So this is something you can attempt if you want. Certainly for this presentation is for my class. And finally, what misconception did you have? So, if you've lasted all this long, thank you for paying attention. I hope this has proven useful to you, and I hope that your VCE computing is going well.